Good morning, students. So, I am Vijayasarathi. I will be taking handling physics for you. So, welcome to the 9th standard classes of physics. So, the first lesson we are going to see is the sound lesson. I think in your earlier classes itself you have been studied about sound, but we will be seeing some interesting factors about the sound and properties of sound in this lesson from now on. So, everyone is aware of sound because we will be hearing through our ears daily. So, you know about the sound and their properties. So, I don't have too much to explain about the sound and what is sound. So, straight away we will go with the properties of sound and the production of sound and what can a sound do and what are the things that are associated with the sound. So, this is your physics class. The title of the lesson is sound, and you all know and what is the sound? It is a type of energy. It is a type of energy. Sound is nothing but a type of energy. You all know the conservation of energy. Conservation of energy, that is, energy can neither be created nor be destroyed. Energy can be converted from one form to another form. For example, we can take the electrical energy. The electrical energy is generated in the dams using some other methods, that is, mechanical energy is converted to electrical energy, and the same electrical energy comes to our home, and the energy that comes as electrical energy, which is converted by the tube light or light into a light energy. So, energy cannot be created by a person. One type of energy can be converted into another type. All the source of energy. What is all the sources of energy? There are lots of energy in our earth, that is mechanical energy, electrical energy, chemical energy. Everything is a form by the source, that is sun. That is a major source of energy. So, like that, energy can neither be created nor be destroyed. It can be transformed from one form to another form. So, like that, sound is also an energy that it cannot be produced as it is. Yeah, mechanical energy can produce a sound energy. So, that is a sound is a type of energy. That energy travels from the source to our ears and it does the vibration over inside our ears, which is transferred to our brain. The brain interprets the signal and converts or makes us to aware of that sound energy. So, that is, sound is a type of energy which is produced by a person or anything that is vibrating, that produces the sound. That sound energy travels and reaches our ears and we get to know about that sound. So, there are also other forms of energy: mechanical energy, heat energy, electrical energy, light energy. Everything is a energy. Like that, the sound is also an energy. Keep in mind the conservation of energy also, that energy cannot be created. Like that, sound is not created, it is produced by some other energy. So, that is the introduction for the energy. You know the tuning fork, you will be using it. This is the tuning fork. When we hit the tuning fork with any material, it starts to vibrate. It starts to vibrate and produces a sound energy. That sound energy can be transferred to other things also. When we touch that energy, touch the tuning fork, we can feel the sound. Because it is on the vibration. It is moving to and fro. Like it will be shaking like this, and it will move the objects which are all brought near to it. So, the sound energy is a type of mechanical energy. The sound energy is a type of mechanical energy. When we bring a ball closer to the tuning fork, it starts to move away from the tuning fork because of the vibration of the tuning fork. When the tuning fork is vibrated and kept near a glass of water, the glass of water starts to vibrate because of the transfer of energy from the tuning fork to the water. When we dip the tuning fork inside the water, we can clearly see the movement of water because of the vibrating tuning fork. So, what is causing the water to vibrate? When we bring a glass of water near to the tuning fork, when we bring a glass of water near to tuning fork, the tuning fork is already vibrating. When we bring the tuning fork closer to the water or near to the surface of the water starts to vibrate. So what causes the water to vibrate? Because of this tuning fork, because of the vibration of the tuning fork. So here the movement is caused by the vibration. So we are going to see about the vibration. Anything that vibrates creates a sound wave. Anything that vibrates creates a sound wave. So what is a vibration? Vibration is a to and fro movement. To and fro movement. So what is a vibration? To and fro movement. You know the swing that we used to play, swing. So it is moving front and to the starting position and then backward from the starting position, that is to and fro. So that is the to and fro movement of the object causes the sound here. You know the guitar, you know the drum, everything produces the sound. We hit the drum with our hand or stick, anything, that hitting causes the drum to vibrate. So that produces a vibration, which in turn produces a to and fro movement, which causes the drum to produce a sound. For example, a guitar. Guitar produces the sound when we pluck the string. When we pluck the string, it produces a vibration in the string, which causes the string to vibrate rapidly. In turn, that vibration produces a sweet noise. So that sweet sound is called as the sound energy. So here the vibration produces a sound. Everywhere the vibration is the only thing that produces the sound. So there are a lot of methods to cause the object to vibrate. It may be a plucking, it may be a scratching, it may be a rubbing. Even the rubbing of the hair also produces a sound. The clapping, that beating of the two hands produces a sound. Blowing, we can blow the whistle out of our mouth. Flute, the flute, when we blow the air out of our mouth, when we make the passage very small, the movement produces a vibration in our mouth, which causes the sound, whistling sound. So that whistling also caused by the vibration of the air. And also shaking, when we rapidly shake something, it produces a vibration around it, which causes the sound. So production of sound, first thing we have seen that the sound is a type of energy, it is a type of mechanical energy, it is a type of mechanical energy, it is a type of mechanical energy. The sound is produced using a mechanical movement of that particular object only produces a sound. So that is the energy type. And next thing is the production of sound. So how the sound can be produced? The sound can be produced by vibrating the body. The sound is produced by vibrating object. That particular vibration can be created. For creating that vibration, we can do a lot of things. The first thing is, let it be a plucking in the case of guitar, plucking in the case of guitar, beating in the case of drums, blowing in the case of flute, scratching, any scratching can produce a sound. We can use simply rub a paper with our hand, which produces a sound. We can using a paper when we wipe out something, or we move the paper over something, let it be a wall or any book, it also produces a sound, that is scratching, rubbing. Even while I am rubbing this board, it produces a sound. So rubbing also produces a sound. Shaking, anything produces a sound. So these are the methods to produce a vibration. That vibration in turn produces a sound. So these are the methods of producing a vibration. These in turn produces a sound. You also know the stretched rubber band. When we stretch a rubber band like this, and when we release that rubber band, it shrinks to its original size. During the shrinking of the time, it produces a vibration that also produces a sound. When we stretch the rubber band, when we can pluck the rubber band like a guitar, and also we can produce a sound. These are the methods of producing the vibration. These vibrations can be produced using this method, and these methods in turn that produces the vibration, and also it produces the sound too. That's all about the production of sound and vibration. So what is a vibration? It is the to and fro movement. It is the to and fro movement. Anything before creating the vibration, that object will be in an equilibrium position. That object will be in equilibrium position. When we do these kind of activities, we set the object in vibration. We just make them to vibrate. So the object will move from the equilibrium position, that is its mean position. From that mean position, it will be displaced to some extent and come back to the original position, and also moves back of that original position and returns to the original position. It will be keep on doing this for a particular period of time. That is called as vibration. That is the to and fro movement of the object. For example, we can take a pendulum. Without disturbance, the pendulum will be in its equilibrium position. When we move the pendulum from here to here, it will come here now. When we release the pendulum, after some time it will be in its old position, and later it will be moving to the position there, and that coming to the original position. It will keep on moving from the original position to the to and fro movement until the energy that we have given to the pendulum fades out. So till there is energy in the pendulum will be moving from the starting position to the original position, and it will make a oscillation. So this is the actual scenario in producing the vibration. We can compare the vibration to that of a oscillation. It is also a oscillation. The vibration is also a type of oscillation also. So how a humans produces the voice? How do we humans produce the voice? We humans produce the voice using our vocal cords. This vocal cord is otherwise called as larynx or voice box. This vocal cord is also called as larynx or voice box. In your biology, you will be studying about the larynx. The larynx have some membranes which are stretched in the cross section of the windpipe, in our windpipe. When we move or when we expel the air out of our lungs, these things vibrates according to the sensation sent by our brain. So for making a word or making a sentence, everything, the brain sends the signals to the vocal cord, and it produces the vibration using the air from the windpipe, air from the lungs. Simply we cannot talk by inhaling, only we can talk by exhaling. During that time, that produces the vibration and it creates the sound in the voice box. How about some bees buzzing around? Bees buzzing sound. Zzz. When they move, flap the little wings very rapidly, comparing to our voice box, the bees will be flapping its wings very rapidly. It produces the vibration. The flapping of wings of the birds, it's to produce the vibration. So these are some methods producing a vibration. A stretched rubber band is also an example of producing vibration. A moving window, a screeching sound. Everything causes the object to vibrate and produces the sound. So that is the vibration. A vibration is nothing but to and fro movement of that particular object which produces the sound. In the case of humans, voice box, bees, wings, birds also wings. When we move the table during the class, some people will be dragging the table without lifting them from the floor. That dragging will cause the table to vibrate around the ground and produce the noise. So every vibration produces a sound, and you all know the medium. You all know the medium to be heard. Can we hear the sound from a long distance? Only when the energy of the sound is more, we can hear the sound from the long distance. Why can't we hear the sound from a long distance when the energy is low? Because during the traveling of the sound, the energy of the sound gets faded out in the medium. So, the sound wave travels through the medium. So, next thing we are going to see is about the medium, that is propagation of the sound. So, we have seen about the vibration, everything. So, until now what we have seen, we have seen what is sound, how can a sound be produced, and what is vibration, what kind of vibrations can be made, and how and all the vibrations can be made, whichever activities can make an object to vibrate. These things we have seen up to now, and next thing we will be seeing about the propagation of sound. Propagation of sound. Propagation of sound is nothing but the movement of sound inside a medium. Let us assume when I am talking to you people, you can hear the sound through your speakers. How you hear the sound through the speakers? From my voice box, the sound is recorded by the microphone. There is some distance between me and the microphone. That distance the sound covers through the air medium. Here the air is present around everywhere. Here the sound travels through the air medium, reaches the microphone, converted to electrical signals that were sent over the microwaves, and you receive the microwave signals, and your phone convert that electrical energy into sound energy. Your speakers in the mobile phone or in your speakers, system speakers, they vibrate and reproduce the sound which were talked by me, and that sound wave travels through the air medium and reaches your ears. So, there the medium plays a most important thing in the sound. So, what is a medium? Anything that allows or anything that surrounds us is called as the medium. And the sound wave, the movement of sound wave, that which allow the medium, the particle which allow the sound wave to pass through or travel through is called as the medium. Anything that allow the sound wave to be transmitted is called as medium. Here the transmission occurs through the air, and there are a lot of mediums available. So, common medium is the air, and but the medium we study there are three kinds of medium: solid medium, liquid medium, and gas medium. Here these are the three kinds of medium through which the sound can be transmitted. So, through which the sound can be transmitted. Without the medium, it is not possible to make the sound to travel through. So, we think about a situation in a spacecraft. In a spacecraft, two persons coming out of the spacecraft and they were talking to each other. Will they be able to hear their sound? No, it is not at all possible, because there is no medium available in the space, because the space is completely made up of vacuum. So, there is no medium available, there is no space for the sound to travel. So, the sound won't travel on the vacuum, only the mediums will allow the sound wave to travel. Here the mediums are, it may be a solid, it may be a liquid, or it may be a gaseous medium. So, the vibration produced by vibrations produced by an object is made to travel through this medium and made to reach on the other end of the medium. So, how the sound wave travel in the medium? For example, my voice box produces a particle, my voice box produces a vibration. The air near to the voice box is made to move. Let us assume the tuning fork problem itself. So, this is a tuning fork. When I vibrate the tuning fork, the air closer to the first arm of the tuning fork moves first. It makes the particle to move. This movement further causes the other particle, because in the, let us assume there is we take this as a medium, it will be filled with that of particles. It is filled with that of particles. When there is a vibration occur, at the verge moment of the production of that vibration, it causes the first particle to move, which in turn causes the other particle to move. It will be simultaneously going on moving the other particles in its way. First thing is, let us assume there are 4 particles. The sound hits this first particle. the vibration hits this particle. This is before the vibration coming near to the particles, they were in the mean position. There is no movement in them. They were simply at the rest position, that is called as equilibrium position. Equilibrium position. So there is no movement in them. There is no movement in them. They were in a still position. When the vibration hits the first particle, this first particle will be displaced from its equilibrium position. It will be displaced from the equilibrium position. When it is displaced, in turn it will displace this particle, and this particle in turn will displace this particle, and it will be keep on moving. So this kind of displacing is called as the propagation of sound. This kind of propagation is called as the propagation the displacement is called as the propagation of sound, and this displacement will occur till the sound reaches our ears. Till the sound reaches our ears. So again, once more again I say it, when the sound producing object is brought near to this particular particle, the force producing the sound will be exerted to this particle. In turn, this particle will be displaced from its original or equilibrium position. So producing a sound is caused by the energy. That energy is transferred to this particle. This particle will be moving from its equilibrium position. In turn, it will exert the force on this particle, and it will be moved from its equilibrium position, and it will be keep on moving up to the sound wave is reaching our ear or to an extent. So the next thing is that this particle will not keep on moving in it through this direction. When it is starts to vibrate, when the vibration is brought near to it, it will start vibrating. It will turn, in turn it will move this particle, and it will move back to the original position itself. So it will not be displaced from this position. It will just move from here to here and come back to its original position. So it will move from the original position, and also it will return back to the original position. So there won't be any displacement of the particle. It won't move the equilibrium position. It will return back to the original position. So keep in mind, they won't be displaced from to another position. There might be some displacement, and it will be coming back to the original position itself. So keep in mind the particles which makes the sound to propagate will first they will be displaced from the original position. When they displace the adjacent particle, it will be moving back to the original position itself. So first of all, they will be moving from this point to this point, and they will return back to the original position. So this is the propagation of sound. Propagation of sound. And the medium, the particles differ according to the medium. The solid will be having different particles, the liquid will be having different particles, and the gas will be having different particles. Gas will be having the different particles. And next thing is the wave. This vibration causes the particle to displace, creates a disturbance. Creates a disturbance. Creates a disturbance. This particular disturbance is called as the wave. This disturbance is called as wave. A wave is nothing but a disturbance caused by the vibrating object. A wave is nothing but the disturbance caused by the vibrating object. So that particular disturbance, once caused by the vibrating object, will keep on moving until it reaches its destination. So that vibration will keep on moving until it reaches the destination position. So here we conclude that sound wave is a wave which is produced by a vibrating object, which transferred from one place to another place by displacing the particles. Since the particles are displaced, we call the sound waves as a mechanical waves. We call the sound waves as a mechanical waves. For example, so there are some particles around them. They are in the equilibrium position. So there is no movement initially in this position. See, the tuning fork is not vibrating now. The tuning fork is not vibrating now. So, they are in the initial position. When the tuning fork starts to vibrate, it will compress these particles. In turn, they will compress the next one, and in turn, they will compress the next one, and the pattern will be like this. So, some particles will be closer, some particles will be wider, some particles again will be closer, some particles will be wider, some particles again become closer. So, this is the movement of the sound. So, here when they vibrate, they compress the particle adjacent to it, and while they compress, there might be some relaxation in the objects that are subsequent to the compression. So, this is a compression, this is a relaxation, this is the again compression, this is again relaxation here. So, those things are called as compression. When the particles displace from its original position, that is called as compression. This relaxation of the particles is called as rarefaction. This relaxation of the particles is called as the rarefaction. Air is the common medium. Air is the common medium of the transfer of sound. So, while we are speaking, we are hearing the sound using the air medium only. While speaking, we are hearing the sound using the air medium only. So, we take the air as the common medium. So, from them we will be seeing the compression and rarefaction. Compression and rarefaction are nothing but when the vibrating object produces a disturbance, first of all they compress the object which are nearer to it, and there might be some relaxation. When the vibration is keep on moving, it will move like a slinky. You know about the slinky? A spring. When we pull the string by one hand, one side, and we lift the string string, there will be compression and moving like this. So, that thing is called as the slinky. You will be using to play. Slinky is the thing that is used to play. We used to play. When we pull the slinky from one side and we lift the slinky, that vibration, that disturbance will make the slinky to move like this. There will be some compression, there will be some relaxation, and again the compression will be moving from one place to the another. Here also likewise, the compression will be moving from here to here, and it will move in a fashion that there will be compression and there will be some low density areas. This is called as the compression and rarefaction. The compression is the place where the particles are crowded, The rarefaction is a place where the particles move apart. There is a low density area. Here in the compression, the particles will be more. Here in the rarefaction, the particles will be less. For a sound wave to travel, we need these two things, that compression and rarefaction also. Without simply by compression, we cannot send the sound from one place to another. So, for sending the sound from one place to another, we need these both the things, that is compression and rarefaction. And also, since the particles are more here, this area is a high pressure area. Here there is a less number of particles around them, so that is called as the low pressure area. So, here the compression is a high pressure area, and this one is a low pressure area. So, the density of the particles will be more in the compression, the density of the particles will be low in the case of rarefaction. I already told you the sound needs a medium to propagate. Without a medium, the sound won't able to travel from one place to another. We will prove that by an experiment which is called as bell jar experiment. We prove them by a bell jar experiment. Bell jar experiment is nothing but an experiment used to prove that sound needs a sound needs a medium to travel. So, that is called as bell jar experiment. The bell jar experiment is used to prove that sound needs a medium to travel from one place to another. It is nothing but a jar which is made up of glass jar. glass jar which has a electric bell placed inside it. Electric bell placed inside it, and those are the electrodes which used to conduct electricity. This used to conduct electricity, and there is a pump connected to it. There is a pump, which is a vacuum pump. A vacuum pump connected to it. Here we use the vacuum pump to suck out all the air that is present inside the jar. We use the vacuum pump to suck out all the air present inside the jar. After that we connect the electrodes to a power supply which makes the bell to ring. Now there is no air present in no air or a feeble amount of air. We cannot suck out all 100% vacuum. We cannot create 100% vacuum here, but we assume that there is no air present inside the jar. Now we make the bell to ring. Will we be able to hear the sound? No, it is not possible to hear the sound because there is no way of sound to be conducted from here to here. The sound travels only through the medium. Since there is no air present around here, we will not be able to hear the sound from the bell. So from this experiment we come to know that the sound needs a medium to travel. So that is called as propagation of sound through a medium. So only with the medium only we can be able to hear the sound. So this is a bell jar experiment. From this experiment we conclude that sound needs a medium to travel. The next thing is sound wave, a type of wave. Sound wave is a longitudinal wave. There are two types of wave, longitudinal wave and a transverse wave. There are two kinds of waves available. So that is longitudinal wave and a transverse wave. Longitudinal wave is a type of wave in which the particles vibrate. So in both the cases the particles will be vibrating, but the type of vibration will determine whether it is a longitudinal wave and or a transverse wave. In this case we have seen the sound wave. So this tuning fork produces a sound. Tuning fork produces a sound. It makes the particle to vibrate. Particles to vibrate near them. Here you can see this vibrating tuning fork will move this first particle. In turn it will move the second particle. In turn it will move the third particle. It will be keep on moving from this direction. Here the person is hearing the sound. So this is the direction of propagation of sound. This is the direction of propagation of sound. From here it reaches the this is the source, this is the destination. From here the sound travels and reaches this destination. Here the particle movement is also on the same side. So here in the case of longitudinal, they travel parallel to the direction of propagation. So when the particles travel parallel to the direction of propagation of sound, it is called as longitudinal wave. In the case of transverse wave, they move perpendicular to the direction of propagation of sound. Of wave. So here the propagation will be parallel, here the propagation will be a perpendicular one. For example, we can take a light wave which will be moving above and below. So here they propagate perpendicular to the direction. Here the wave is moving in this direction, but the particle is moving from above and below. So when the particle is moving above and below, we call them as transverse wave, and if it is moving parallel to the direction of propagation, we call them as the longitudinal wave. So keep in mind Longitudinal wave is the wave where the particles vibrating will move parallel to the direction of propagation, and transverse waves are the waves in which the particles will move perpendicular to the direction of propagation of the wave. So, these are something you have to keep in mind. In later in the later classes we will discuss them, and next we will see the characteristics of the sound. What are all the things? Characteristics sound. There are few characteristics of sound that determines the type of sound, or how the sound will be heard by us, and how long it can be heard, and its intensity and its loudness. Everything is based on this characteristics. And it is the quality of the sound is also determined by the characteristics of the sound. So, the first characteristics we are going to see is the frequency. Next thing is wavelength, time period, speed of sound, speed. Everything about a sound will be determined using these characteristics only. So, the frequency we have already seen in earlier classes also. Frequency is how frequently a thing happens. Frequency is nothing but how frequently a thing is happening, that is called as frequency. A frequency is nothing but how frequently a thing is happening. So, that is frequency. It will be calculated using a unit time. For example, let us say that an object is vibrating. An object is vibrating and it is producing a sound. So, in that, for calculating the frequency, we are going to see that in a unit time, how many times did that object vibrated? How many times did that object vibrated? That will give you the frequency in a unit time. So, the frequency is calculated how many times that particular object vibrated in a given unit time. So, that is frequency, and it is measured in hertz. It is measured in hertz. Let us assume that an object is vibrating 100 times. 100 times per second. 100 times per second. So, that object is vibrating in a second 100 times. It is vibrating 100 times in a second. Then we call them as 100 hertz. So, can you understand more clearly? The frequency is the number of times the object is vibrating in a given time. We take that given time as second. So, we calculate for every second. So, the object vibrating in this example we have seen that particular object is vibrating 100 times in a second. So, we call them as 100 hertz. And the next thing is wavelength. Wavelength. So, what is a wavelength? The length of a particular wave is called as the wavelength. In theoretic, schematically we have seen the movement of the compression and rarefaction. So, this is the compression and rarefaction moving through the air. This is the compression, this is the rarefaction, again compression, again rarefaction, again compression. For the diagrammatic representation, we make a diagram. Here the compression is made as a peak in the wave, and the depression, that is the crust in the wave, is the rarefaction. Again there is a compression, again there is a. For understanding, we make this diagram into a graphical format. Here the peaks, that is above the mean level, shows you the compression. The depression, that is the valley. This is the peak, this is the valley. Shows you the peak shows the compression, the valley shows the rarefaction. Here also the peak shows the compression, here the valley shows the rarefaction. Again there is a peak. Again there is a peak. So, the distance between the two consecutive peaks, the peak and the values of peak or crest, valley or trough, valley or trough. The peak is also called as crest, the valley is also called as trough. The distance between the two consecutive crests or the two consecutive trough, the distance between the two consecutive crest or the two consecutive trough, this particular distance will give you the wavelength, that is the length of a single wave, the length of a single wave. How can you say a single wave, how can you catch a single wave and measure a distance? Only by using this method, that peak to peak or valley to valley. The peak is called as crest, the valley is called as trough, because we cannot get the mean value, so only we are catching the wave using the crest or valley. So the distance between the two consecutive, keep in mind that two consecutive crest, not simply two crest or two trough, consecutive crest or consecutive trough. So the distance between the two consecutive crest or two consecutive trough will give you the value for the wavelength. It is also measured in lambda, it is called as lambda. Lambda, this one will be measured in nu. Pronounce that nu, pronounce as nu. What is the time period? What is the time period? The time period is the time taken for this particular sound wave for completing one oscillation, Time period is nothing but the time taken for the particular wave to complete one oscillation. Here you can assume that it is in the peak position. From this we are going to record the time. Now it moves to the equilibrium position, then to the valley, then to the equilibrium position, then again to the peak. So the time taken for the wave to move from this place to this place is called as the time period. So time period is nothing but time taken by the vibrating object, time taken by the wave to complete one oscillation. So that is time period, and speed is nothing but the distance covered in time. Speed is the distance covered by the time. So there is a formula relating the things around it. Here the frequency, that is V nu is equal to 1 by T, because we are calculating the frequency for the 1 second and time period is the time taken for the completing one oscillation. So we relate these two things and bring this formula, nu is equal to 1 by T, nu is equal to 1 by T. So that is nu is the frequency and it is equal to 1 by T. This is the relation between the frequency and the time period, and keep in mind all these things, the frequency, wavelength, time period and speed. There is one more property, that is amplitude. Amplitude is nothing but the maximum displacement from the mean position. Maximum displacement from the mean position. Here the object is displaced more, the wave is displaced more. Here the wave is displaced less, but the frequency is same. The wavelength is same. Only the movement of the movement of the particle from the mean position is more. Here it is displaced more, here it is displaced less. That property determines the amplitude. The intensity of the sound or loudness of the sound determined by amplitude. When the amplitude is more, the energy of the sound is more. When the amplitude is less, the energy of the sound is also less. So that is amplitude. It is measured in decibel. So these are the properties you have to keep in mind. That is frequency, that is the number of times the vibrating object produces the vibration in a unit time. We take the unit time as 1 second, and wavelength is the distance between the two consecutive crests or the distance between the two consecutive trough. Time period is nothing but the time taken to complete one oscillation, and the speed is the time taken for the wave to travel a particular distance in a given time. So amplitude is the maximum displacement from the mean position. Amplitude is nothing but the maximum displacement from the mean position. If the displacement is more, the energy of the sound wave is more. When the amplitude is more, the sound wave can travel to a long distance. When the amplitude is less, the sound wave can travel only a less amount of distance. We can see the remaining things in our next class, about the things that are connecting the frequency, wavelength, time period, everything we can see it in the next class, and the problems based on the speed, distance, time, everything can be seen on the next class. As far as now, you keep in mind what is sound, how a sound is produced, the propagation of sound in a medium, what are all the mediums available, how the sound wave travels in the medium, what kind of wave is a sound wave, and how the sound wave travels in the medium, that is compression, rarefaction. And the next thing, the characteristics of sound. What are the characteristics of sound? That is frequency, wavelength, time period, speed, amplitude, everything determines the quality and characteristics of the sound. So that's all for now. We will see the remaining things in our next class.